see, so first of all, somebody asked a question. Let me just address it first. It goes from exam 1. They asked on exam 1, number 17. They weren't sure why that point D. Let's take a look at that. So these are all 4 exams. These are the fall 24. We'll mainly look at those unless y'all have some other particular questions. But number 17, somebody wrote me and they were uncertain about why this statement is true, that the acceleration at point D is negative. The acceleration right there. Notice we are looking at a position versus time graph, so the slope of that gives the velocity. So probably the reason that you're confused about that, and a number of you are confused about that, is because the slope there is equal to 0, and so people tend to think, oh, the acceleration is 0 as well, but it's not. So if you remember, when we have an object that goes up and then comes back down again, like that we represent the y versus t graph for that motion. It looks like this. Starts out with a big positive velocity. At the top, it has a 0 velocity, and then it ends with a big negative velocity. Looking at the position versus time graph, notice that this little section of the graph looks a lot like that. It's an upside down parabola. And so it's going to describe the acceleration in the same way. If I were to plot the Vy versus t graph for that, it would look like that. Right, we actually did that in lab, right, where you dropped an object, or this was the y position as you had the object throwing. It goes up and comes back down again. This is the point at the top of the trajectory where the velocity is equal to 0, but notice here that the acceleration is not 0. That in fact the acceleration is minus 10 meters per second squared. And just because the velocity versus time graph, or excuse me, the position versus time graph has 0 slope, that doesn't mean that the acceleration is 0. In fact, it's not going to be 0 because the velocity is changing at that point. That it's going from really big to 0 to really small, or to get it to increasing, going from big, decreasing to stopping, and then its speed will increase. So it definitely has an acceleration there, even though the slope of that function at that point is 0. Okay? Is that clear? That is going to come up several times on the exam. I have several graphic questions. You're probably not surprised about that. It was on a couple of exams. All right. Are y'all aware of what the free response looks like for the exam? Cut and paste, y'all. So make sure you get those exactly right. Practice them until you just know them. I did flip the direction of the inclined plane, so it's a little bit different. It just changes the signs of the x-axis. That up is negative, I think. I forget how it was before. Anyway, it switches the signs, but it's the same. So I want 100% on those 3 responses. All right? Otherwise, 10 questions from each exam. In some cases, just a very limited number of cases, I've just changed the numbers. And it's still the same question, but that's only a few questions. Of the 40, most of them have been changed, fairly substantially, where I'm asking you for a different variable, that you're solving for a different variable, or if you have those statements, I've just erased all the statements and rewritten them. They're still about the same topics. In fact, I tried to make the statements still asking around the same ideas, testing the same ideas, but they're different questions. So don't think that it's going to be an easy exam. It's not going to be easy. I want you to prepare for it. And if you prepare, you'll do well. All right? Questions? Particular questions? Yeah, Benjamin?
The last one of this exam, exam 4.
Exam 4? Number 20?
Yes.
Okay. This one about the tendon in your arm? Yeah. So you want to know how much it stretches. This is a tension, or not a tension problem, a stress and strain problem. So F over A is equal to Y delta L over L. And I'm looking for delta L. Okay? So I solve that for delta L. I find that delta L is equal to FL over AY. I just solved that for delta L. And then I put in the quantities for it. F, I give you, is 100 newtons. L is the original length. So whatever the length was before the force was applied is going to be 0.1 meters. It's a 10 centimeter tendon in your arm. It has a cross-sectional area of 7.5 times 10 to the minus 5. And this might have been where you got stuck, is what is the Young's modulus? That's on your equation sheet. For a tendon, the Young's modulus is, where's my website? You will have the full equation sheet. It'll be on a separate sheet so you can tear it off and look at it. That tendon has a Young's modulus of 2 times 10 to the 7th. That's right down here in that table of Young's moduli. So that's 2 times 10 to the 7th. And that's 10 divided by 15-ish. 2 over, I don't know, what was it? It was like 0.7 centimeters? Is that what it was? Yeah, so B is the right answer. Okay? Is that clear? All right. Jude? Okay. Okay, a lot of people missed this question, okay? There were 2 questions. I forget this one and then one other. So if a lot of people missed it, I like to see that question again, you know, because I want to make sure y'all know it. This was a tension centripetal force problem. At the top of the trajectory right here, I tell you that the tension in the string is 0. So the only force that's acting on this is the weight. And because that's the only force that's towards the center of the circle, so I know there's no tension because I say at the top of the circle, the string has no tension. There's no tension in the string. If you've ever done a yo-yo like this or swung anything around in a circle, you know as it goes up high, the string can go slack, right? You've ever done that where you swing something around? If you do it slow enough, the string will sort of relax at the top of the trajectory. Anyway, the force weight is towards the center of the circle. It's a center-seeking force. That is our centripetal force. So even though this problem looks complicated, it's really not. The force weight is our centripetal force, which is m omega squared r. Usually we see that centripetal force as mv squared over r, but I'm asking for omega, so it's a little easier to express it in that way. I think that's also on your equation sheet. Let's just double check that. The centripetal force is, no, it's just given as mv squared over r, but you have to substitute this in for v, and then that equation becomes m omega squared r. Okay. Anyway, so once we do that, we say that mg equals m omega squared r. The m's cancel out, and then I solve for omega. That's the square root of what? G over r. And the answer was, well, 10 over 0.1, the square root of 100. It was 10, right? 10 radians per second? Is that the answer? Square root, did I do that wrong? Oh, the radius is 10, is 1 rather. So it's 10 over 1, so it's the square root of 10. Now, if I gave the only other option that I could give you, I wouldn't give it to you where it's out here. Well, I could, but I won't. But the only other scenario is what if the object is at the bottom? And in that case, you're always going to have a tension that's acting upwards, and you're going to have a weight that's acting downwards. Okay? I would tell you what the tension is. So let's say, for example, I tell you the tension is, I don't know, I'm just pulling a number, 5 newtons. I would say, hey, the tension when it goes down at the bottom is 5 newtons. And then I would ask you the same question, what is omega? The way you do that is you would say, well, the sum of the forces is Ft minus Fw, which is equal to m omega squared r. And now that you know Ft, and you know Fw too, because you know the mass of the yo-yo, then you can solve for omega. Is that clear? Good question. Yeah, you have to. Number 13. Okay, so this was a torques problem. I think that people missed it. It wasn't widely missed, but a number of you did. Was just you had to sort of estimate things. You had to estimate the ratio of this distance to this distance. I tell you that first distance, I say that the insertion point is just a few centimeters from the elbow. That means that the bicep is attached right there, and so the force acting on the bicep is acting in that place. And then there's another force, which is the weight of that soup can, or whatever he's holding, which is equal to 1 pound. All right, and I want to know what is the force of the bicep. Because this distance, the ratio of that distance to this distance is about, well, given the answer, it's about 8. So that means that whatever force you have here is magnified by a factor of 8. Let me show you what that would look like. I'll just put in some numbers. So let's say that this is my bicep, FB. We'll say that this distance is 3 centimeters. That's what I said. I just gave you an estimate of a few centimeters. And then the weight here is 1 pound. This distance is then 24 centimeters, roughly. About the distance of your forearm, about 24, 10, yeah, about 24, 25 centimeters or so. So I would say 1 pound times 24, 1 pound times 24 centimeters is equal to FB times 3 centimeters. And then I solve that for FB, and that's equal to 8 pounds. It's a class 3 lever, if you remember that from high school physical science, where you have the axis of rotation, the effort force, and the resistance force. When the effort force is in between the axis of rotation and the resistance force. Jog in your 9th grade memories at all? Probably not yet. But this force is always going to be bigger than this force. Okay, if you see this problem again, just remember that that bicep is going to exert about 10 times the force that is pushing down on it. Is that clear yet? Yeah. What else, John?
Number 10 on this test.
10. Okay, total moment of inertia. This is a situation where you have an object, and then you have a particle that you're adding to it. We've seen problems like this in class, like with the kid that jumps onto the merry-go-round or the spinning wheel, and you put the lump of clay on the edge. I start with this thin rod, and the moment of inertia of that is equal to 1/12 mb squared. That's in your equation sheet. That's 1/12 of the mass, which is 6 kilograms. Be careful, there are 2 masses. It's the mass of the rod. And then the length of the rod is 4 squared. It's 2 times 4, that's 8, I think. So that's the moment of inertia of the rod itself. And then I place this thing's spinning about this axis. I place a 3 kilogram mass right here. And I want to find what is the moment of inertia. That moment of inertia of that particle, this is a particle, not a sphere or anything like that. That's just going to be mr squared, which is 3 kilograms times that distance, which is 2 meters squared, which is equal to 12. So 12 plus 8 should have been C. Right, C was right? Yeah, okay. You definitely will see this. This came up quite a few times in the exam where you had to find a total moment of inertia. In this case, you have the bar, and then you have a particle. It might have been difficult to understand that this was a particle, but a good key or hint that it's not a shape is I don't give you any dimensions of this. I don't give you a radius or a length or anything like that. And so if you get a situation where I don't give you any dimensions, then just think, oh, that must be a particle. Okay? And then ask yourself the question of how far is it from the axis of rotation? And that's the important distance in that I equal mr squared. Okay? All right. What else? Yeah.
Yeah. 15 on the same test.
Yeah. Okay, so boat has a volume of 3.2 cubic meters, and it has a mass of 500 kilograms. I just want to know what total mass can it carry. First, you can just calculate the buoyant force. The buoyant force is equal to rho Vg. That's the density of the fluid, the volume of the object, and the acceleration due to gravity. The fluid is water, unless you're in a lake of lava or something, and then I guess it's lava. The volume of the object is 3.2, and then G is 10, so that's 32,000 newtons. Okay, that's the buoyant force. However, there's already a weight of the boat. The force weight of the boat is equal to 500 times g, which is 5,000 newtons. So that means that I can I already pick up 5,000 of these in the buoyant force of these newtons, but I can put additional weight in the boat without having it sink. And that additional weight would be 32,000 minus 5,000, what's that, 27,000 newtons. So the difference in that, FB minus FW, is 27,000 newtons. But I'm asking for mass here, so you'd have to do divided by g to get the mass, so it's 2,700 kilograms. So a couple of things, you have to know the buoyant force, and then realize that the boat already takes up some of that buoyant force, right? And then in addition to that, what else can you put into the boat? In this case, that's 2,700 kilograms. Okay? Yeah. Number 2, same test. Okay, angular speed of the hand. You don't really know analog clocks very well, do you? Do you? Yeah, you do. It's okay. So I have a displacement here, theta, which is, what's that? How many radians is that? It's 180 degrees, but I need in radians. That's pi radians, right? It's pi. It is clockwise, so that means that it's negative, but the negative is not important because I'm just asking for the speed. And then I want to know, this is a second hand. It says it moves from 45 to 15. That means that the time is equal to 30 seconds. So the speed is going to be pi over 30, or roughly 3 over 30, which is about 0.1. Okay? What other? Yeah, math. Okay, total energy. There were 2 energies that you had to find. You had to find the translational kinetic energy. That kinetic energy is 1/2 mv squared. The mass of the ball is 0.2. The speed of the ball is 30. That's squared. It's 0.1 times 900. That's 90 joules. And then you also had to find, this is the translational. Then you also had to find the rotational, which is 1/2 of I omega squared. Now I need to find, it's a softball. That's a solid sphere. So I look over at my equation sheet. It's like a solid sphere is 2/5 mr squared. That's 0.2. R is 0.05. That's squared. Oh, that is right off. Let's see. I get 0.0002. So it's 1/2 of 0.0002. And then omega, I did give you omega actually. It's 125 radians per second squared. And so that energy times 0.5 times 125 squared is 1.56 joules, or 2 joules. And so the total energy is the sum of those two, are 92 joules. Honestly, though, like if you looked at the options, once I found out the translation, I could have stopped there, right? Because no other answer is under 90. But the tricky part here is making sure that you calculate I, and in past versions, I haven't given you omega, like you had to find it. No, never mind. No, I've done that. Yeah, never, forget that. You won't see that. I mean, you might see that problem, but I'll give you the omega. All right, what else, y'all? That's a lot of exam 4, but 3/4 of the exam is exams 1 through 3. And exam 2 is probably the hardest. Go.
Exam 3, question 3.
Number 3? We can come back to this one if y'all have questions. Number 3, you said, right? Okay, so I want to know, this one with the cheerleader? Yeah. I want to know her speed when she goes through the basketball hoop. So then understand what types of energy she has at various places. Here she has only potential energy, and here she has potential energy plus kinetic energy. And those are going to be equal to one another. So mg times 6 is equal to, that's the potential energy, mgh, I just put in the h, is equal to mg times 3 plus 1/2 of mv squared. I can cancel all the m's because they're in every term. Be careful, you cannot cancel the g's. I've seen students do that, but you can't do that because there's not a g in that last term. So that's going to be 60 equals 30 plus 1/2 v squared. So v is 60 minus 30 times 2 is roughly the square root of 60. Um, 7.7? Yeah, 7.7. We had a couple problems that were like that, where you're looking at the energy of an object going up and down. What else? Yeah. Okay, so there are a number of these statement kind of questions. I mean, there are a couple on every exam, so be prepared for them. So here, the force F is dependent only on the mass of the block. I don't say anything about how the elevator is moving. So the force is dependent upon not just the mass of the block, but also the acceleration of the elevator. If it's going up, you'll have a force that's bigger than the weight of the block. If you're going down, you have a force that's lesser than the weight of the block. So that's not true. Negative acceleration means the elevator is moving downward. Just in general, that's not true. That you can have negative acceleration even as he's moving up. Like if you're moving up, but you're slowing down, that's negative acceleration. So that's not true. If it's accelerating downward, F is smaller than the weight of the block. True? Is that statement true? It is true, right. It's like you get in an elevator that's going downward, you sort of feel like you come up off your feet a little bit. If the elevator moves up at a constant velocity, F is equal to the weight of the block. True or not true? Yes, true. So 3 and 4 are the right answers. If you're uncertain, you can go through, like if you know that 1 is definitely wrong, like if you know that 1 is, the first statement is definitely wrong, and that gets rid of that one and that one. And if you know that 2 is definitely wrong, and that gets rid of that one and that one. So you can use some order of elimination to make those problems easier. But I do know sort of what you think may or may not be right. So I try to have the options to sort of tease out that misunderstanding a little bit. Okay, so just be careful on that. All right, what else? Yeah. 19 on test 2. Sorry, excuse me. This is test 2, right? Okay. There were a couple of these problems. Y'all had difficulties with 16 and 19. What is the force F here? So I give you the acceleration. Since I give you the acceleration in this direction, the acceleration is 5 meters per second squared, then you should be able to find the net force. Let's just go ahead and write the rest of the forces, actually. I know I have a frictional force in that direction, I have a weight in this direction, and I have a normal force. And then I'm just going to redraw this force down here. It makes a little more sense to draw it down there. But it's like you're pushing down on top of the block. Oh, and then I have this tension that's pulling along here, Ft. So the sum of the forces in the x direction, which are Ft minus F, is equal to ma. Ft I know is 20, minus F, I don't know what F is, but I know the mass, that's 2 kilograms, times the acceleration, which is 5 meters per second squared. So F then is equal to 10 newtons. This force is 10 newtons. I want to know what is that force F. So I know that this force is related to both the normal force and the weight. In fact, I could say that the normal force minus F minus FW is equal to 0 because it's not accelerating in the y direction. You with me, Avery? You good? So far? Okay. If I can find Fn, I can find F because I know what Fw is. If I know what Fn is, then I can find F. So I need to find Fn. I know that F is equal to mu times the normal force. I found F, that's 10 divided by mu, which is 0.1. That's equal to the normal force, which is equal to 100 newtons. So I have 100 minus F minus Fw, which is 20, that's 2 times g, is equal to 0. So F is equal to 80 newtons. A is the right answer. It's a hard problem, and y'all, a lot of y'all did miss that problem. Y'all see that? Do you see that, Avery? Okay. So you'll likely to see it again. But in a variation, so make sure that you're not just memorizing it, that you actually understand. Okay? All right. What else, y'all? What else? Yeah.
Can we do 20?
20 on the same exam? All right, another, this whole series of questions, number 19, number 20, number 16, I don't think all three of them made it on the exam. Honestly, I don't remember which ones, but they were all questions that y'all had difficulty with. So here I want to know the rate of the acceleration. By the way, like if I were to give you this problem, I would probably not ask you for the acceleration, but I'd probably like give you the acceleration and ask you for something else, like the coefficient of kinetic friction or the normal force or something like that. Okay, so as you're practicing these, think through that. Okay, I'm not just trying to learn this particular problem, but I want to learn what is the procedure to get to that, to approach that problem. All right, so I want to know the acceleration. I'll start just by drawing my forces. I have a weight. I have a frictional force, I know. And then I have this, calculator go. I have this force that's broken down into two components. This one is going to be 30 sine of 30, which is 15 newtons, and then 30 cosine of 30, which is 26 newtons. I just resolved that force into its components. And then I also know that this force weight is 150 newtons. And I know I have another force actually here that is my normal force. So notice here that the normal force is not equal to the weight because I have this other force that's pulling up. The sum of the forces in the y direction are equal to 0. That's Fn plus 15 minus 150 is equal to 0. So Fn is equal to, what, 135? That's my normal force. And then I can find, the next step is to find my frictional force, which is mu times the normal force. That's 0.1 times the normal force. That's 14 newtons. We'll just round it off to 14. And then finally, I want to know the acceleration. I would say the sum of the forces in the x direction, that's 26 minus 14 equals m times a. So a is equal to 12 divided by the mass, which is 15. I get 0.8. Was it 0.83? It must have been 0.83. Was that the right answer? Yeah. Probably shouldn't have rounded that. Frictional force. Okay. Is that good? We're good? Yeah, go ahead. For the frictional force here, so I first had to, when I'm starting out, I want to find the acceleration in the x direction. So in order to do that, I know I have to do the sum of the forces in the x direction is equal to MAS. So when I started this, I knew that I was getting to this point, where the sum of the forces in the x direction is equal to MA, because I want to know what is that acceleration. So I know one of those forces is the x component of that force. The other is this frictional force. I have to find that. The frictional force, however, I know is mu times the normal force. So I went about finding the normal force. The normal force I find from analyzing these forces, and I find that this is 135 newtons. 135 plus 15 is equal to 150. I did that here, finding the normal force. The normal force is 150 minus 15. Because I have that 15 newton force pulling up on the plot. And then once I find the normal force, then I can find the frictional force. I rounded it off, so it should be 13.5. I think that's why my decimals didn't come out right. But 13.5, and then I do that to some of the forces in the x to find the acceleration. Is that good? Important. Okay. Benjamin?
Just a question. So, all right,
Okay. Good. Yeah. Number 12 on exam 1, kinematics problem. I recommend that you start writing down the things that are in the problem. So like for example, I know here that x is equal to 400, t is equal to 43 seconds. And I also know it's not stated here, but I know that these runners, that they don't get a head start, right? So the initial velocity is 0 meters per second. And I want to know what is the final velocity. I know that this is equal to v naught plus at. I know what t is, but I don't know what a is. So I have to find the acceleration. My other kinematics equation, which you won't have on the equation sheet, but they're the same as the rotational equation. So if you know that x is theta, v is omega, a is alpha, then you'll have those in front of you. Anyway, x is equal to v naught t plus 1/2 at squared. V naught is 0, so that term goes away. And so x, which is 400, is equal to 1/2 of a times 43 squared. And I solve that for a, and that's 800 divided by 43 squared. Which is 0.43 meters per second squared. And then the final velocity would be equal to 0 plus 0.43 times the time, which was 43 seconds, which is what was it, 19? Yeah, 19. Okay. In real life, of course, Yenta, you run 400, right? Either. Like in real life, that the runner doesn't accelerate the whole time. That most of their acceleration occurs in the first, how many meters? 10, 20, huh? Okay. Yeah, so it happens pretty quickly, but, it's not always real life, right? Okay. What else? I don't remember who asked that. Yeah, that's.
We have to know how to do question 11 from quiz 1, or not really? It was about converting a kilometer squared to acres.
Maybe. You want to do this one?
It's 10?
Number 10.
Yeah.
Yeah. I don't know. I mean, I guess it depends how much you consider wetlands loss in Louisiana to be important. Pretty important? Yeah. All right. Do you want to do this one? You did it early. Okay. Yeah. This one was a hard unit conversion. You want to convert your square kilometer. It was difficult because you squared some of the conversion factors, but not the others. So just watch your units and write your units. So 75 square kilometers. And then I want to convert that into acres. So first, I'm going to convert it into feet, or I'll convert it into meters first. 1 kilometer is 1,000 meters. But I have to square that so that these units will cancel those units. Right, look at your units and follow those. Next, I want to convert my meters to feet. 1 meter is 3.28 feet. But again, I have to square this too. So I cancels this meters with that meters, because they're squared. They're both squared. And then finally, I need to convert from feet to acres, or square feet to acres. I like to say that 1 acre then, I just sort of do this on the side, is 66 by 660, which is 43,560. I keep all sig figs because it's a conversion factor. So that's 43,560 feet squared, canceling out with these feet squared, is equivalent to 1 acre. But I don't square that last conversion factor. It's like I've already done the square right here. So this number is feet squared, but this is not acre squared. I don't even know what an acre squared is. What would an acre squared be? I don't know. That would like go into some weird fourth dimension or something. Okay. And then whatever that answer is, I don't remember what it was. 19,000. Yeah. All acres. Isn't it 19,000 acres? Y'all probably seen lessons off just like in your life. If you go out fishing, like you find places that were once land that are no longer land. Is that right? Yeah. Okay. Well, yeah.
For exam 3, question number 8, the one you took off of that, of like, you have to,
Is it this test?
until the back, number 8.
I'm pretty sure I did not put it on there. Yeah, because there was a problem, right? Yeah, no, I didn't put that one on there. Only one student noticed the problem. A little disappointed. It was subtle. All right, what else? Okay. That number 8, consider the previous problem. The plot goes upward. What happens to the 3 types of energies? Right, because yeah. What else? Number 11. Okay, what is the work done by the force? In fact, this was a series of questions, right? I think there was that one, and number 12, and number 13. So there were 3 questions about it on this test. You can probably bet, right? It'll be on your test too. Fortunately, it's not that hard. If I want to know the work done by the force F, that work is just going to be FD cosine theta. That's 4 times D, which is 2, times cosine of 30. So that's equal to 6.9 joules. So that was the answer for that one. If you want to know the total work, this force does a total work of 4 joules, actually negative 4 joules. So the total amount of work would be 6.9 minus 4, which is 2.9 joules. If I asked you what is the work done by this force, it does 0 work. This one does 0 work. The y component of this one also does 0 work. Okay, so there are 3 questions on this exam. You bet there's at least going to be one. What is the work done by any one of those forces, or what is the total work? Matt? This force right here is perpendicular to the displacement, so it doesn't do any work. That's why this cosine theta term, if it's perpendicular, that angle is 90 degrees, and the cosine of 90 is 0. Okay? I forgot who asked that. Who asked that? What are you guys over there? That's good? All right. What else? Yeah.
How do you convert the 2 to 4 joules? Is it like,
Oh, I'm sorry. Yeah. So the work done by that force is equal to FD cosine theta. That's 2 newtons times 2 meters times the cosine of 180. And that's equal to negative 4. I just multiplied it times the displacement. And since the force was opposite the displacement, then I know it's negative. That's the cosine 180. Cosine 180 is negative 1. Dylan, I didn't see you back there. Somebody else wants, oh, Adam. All right, what else, y'all? I feel okay about this exam? Most of you have it tomorrow, right? Yeah. Okay,
On that final, is it gonna be like the questions are separated by chapter?
of course, yeah. I always do that.
What?
What do you mean?
Like, isn't okay, man?
There are roughly 9 to 11 questions per chapter. Okay, I don't remember which that's what. Would you like me to print it out for you and just give it to you right now?
That'd be great.
Yeah, right.
I'll keep it on.
Yeah, right. Okay? Any other questions? All right, I think I got everybody, but just check with me as you head out.